really, the the mitochondria are found in the tail part of the sperm. So during fertilization, it's only the head that gets inside the nucleus. The egg. So it's the tail part cannot get in to the cell, and fertilization right away occurs. So immediately after fertilization, zygote is formed. So the tail part will just be degenerated after the head part penetrates the egg. So the mitochondrial DNA cannot be a constituent for the zygote formation, only of the sperm, only the egg mitochondria. So that's why there are traits or genes of which only mothers can donate. So if I were you, men, boys, now if you want to say to have children possessing desirable traits, you choose those whites to be possessing desirable traits, because they contribute more of the genetic materials of your children than you can. So that's how mother influences the kids. Not only in terms of genetic materials, they contribute more because of these mitochondrial DNAs, plus of course the influence. So the environment. Okay? Now, there are two parts of this catabolic pathway. You have the citric acid cycle or the Krebs cycle, or we also term that as tricarboxylic acid cycle, or TCA. Now, and of course, the electron transfer chain. And we have these four principal compounds participating in the catabolic pathways or the breakdown process. So of course you have the ATP or the adenosine triphosphate, or of course when it is hydrolyzed it becomes adenosine monophosphate or adenosine diphosphate. It depends on how many phosphates were being released or broken. Now these are this molecule is the energy currency of the cell. So when we say energy currency, that is the source of energy for all cellular activities. Now, so those glucose are not just energy class. Are you with me? They have to undergo, when they are already inside the cell has to break them so that they will be converted into the energy currency, which is adenosine triphosphate. Get it? And the breaking process involves the process called cellular respiration, which involves three major processes. First, glycolysis, which occurs in the cytosol. We say cytosol, the fluid part of the cytoplasm. Then you have the citric acid cycle or the Krebs cycle, second, which occurs in the matrix. And yeah, it's part of the mitochondrion or mitochondria. And then you have the electron transfer chain, which is part of mitochondria, which is the cristae. So that's the site for the electron transfer chain. So there will be energy generation. So how is energy generated? Out of glucose. So you have there the glycolysis, the Krebs cycle, and the electron transfer chain. Now these are mga different compounds which participate in the breakdown process. So we also have the NAD or nicotinamide adenine dinucleotide. Now when electrons are released during the breakdown process, then these electrons are being accepted or carried by NAD or nicotinamide adenine dinucleotide, so that becomes NADH. So this is the reduced form of NAD. So when NAD accepted the electrons or gained the electrons, then they are reduced. So they become NADH. When they give off, that becomes NAD plus. Why it's plus? No? Because they already lose, this molecule loses electron. So positive na yung charge. Electron is negative. So pag give off sa electron, so the charge is already positive. So NAD. So this is an oxidized form. This is a reduced form. Now the same is true with this FAD, fluorine adenine dinucleotide. So this will another electron acceptor or electron carrier, which of course undergoes reduction, and one molecule can accept 2 electrons. So it will accept 2 electrons, so it is reduced. This is in a reduced form, and this is the oxidized form. We also have the coenzymes. Coenzyme A, mga coenzymes, which is part of the holoenzyme, which is part of the holoenzyme. So this contains mga organic molecules, mga organic areas, like for example vitamins. So coenzyme A consists of pantothenic. Later on, I'll project pantothenic acid. So you have here, it is abbreviated as CoA or CoASH. Meaning na siya is hydryl. So you have the SH or sulfur. Now you have there, this is the adenosine. This portion is the adenosine. This is the 5-carbon sugar, the ribose or beta-D-ribose or ribofuranose, and this is now the adenine. This is the adenine. And this adenine and the ribose is bonded with glycosidic bond. So this is the adenosine. Then this portion, triphosphate, meaning tulo ka phosphate bonded together. Now we have these 2 bonds found here in these phosphates. One phosphate, which is bonded with the ribose, is called the phosphoric ester. Now, phosphoric ester is a weak bond. The cell will not break this bond because this consists only of a few energy. So, this will not be broken during hydrolysis. However, these 2 phosphates, this another phosphate, these 2 remaining phosphates have 2 bonds called the phosphoric anhydrides, which are energy-rich bonds. So, when the cell requires energy out of ATP, this bond, the phosphoric anhydrides, are the one that are being broken. Pag break ani, ma-release ang energy, muna din gamiton sa cell. Get it? Okay, are you with me? So the phosphoric anhydrides are used for cellular activities, energy source for cellular activities. That is when the ATP is hydrolyzed. And phosphoric ester is not. That's why there's no such thing as, say, when ATP becomes adenosine only, meaning all the bonds were broken, then 3 phosphates were broken. No. So 1 phosphate is remained, which is attached to the ribose, held by phosphoric ester. This will not be used by the cell. Only these 2 phosphates here. So natay adenosine monophosphate, meaning isa na naka-phosphate, duha na release. Or adenosine diphosphate, meaning isa lang ka-phosphate ang release. That is the bond here, 1 phosphoric anhydride is being broken, releasing the energy used by the cell or cellular activities. So that is what happened, class. Now in every phosphoric anhydride that is broken, so in every hydrolysis, say 1 phosphate is removed. So that is breaking of the saccharide, it gives off 7.3 kilocalorie per molecule. So, these 7.3 kilocalories, these are energy that will be utilized by cellular activities. So, kung duha ka phosphates ang na-remove, so 14.6. Also, ang from adenosine triphosphate, may mo na lang adenosine monophosphate. So, that 14.6 kilocalories were being used by cellular activities. Okay? So, this is the cellular or the currency of the cell. No? Yung currency, mura ba siya piso? No? It's like a peso coin. Of course, you cannot eat the peso, but when you buy something, you can eat out of that peso coin. Get it? So the same is true with ATP. The ATP cannot be used by the cell as energy source straight away. It has to be broken. It has to undergo hydrolysis. So asa ni siya gikan ang ATP? This comes from glucose, breakdown of glucose, and then breakdown of glycerol, breakdown of fatty acids, breakdown of amino acids. So that is where ATPs are coming from. Get it? So they are for cellular activities. This is the universal carrier of phosphate groups, the ATP. So you have this picture, the nicotinamide, adenine dinucleotide, or the NAD, which is an oxidizing agent. When we say oxidizing agent, it is a molecule that gives off or donates the electron. Okay, so you have here another flavine adenine dinucleotide, or the fat, another oxidizing agent. So you will encounter this when we discuss with our topic. Flavine adenine dinucleotide, or the fat. So another oxidizing agent. Okay. Then we also have coenzyme A. This is the acetyl carrying group. Now, it's often written as CoASH. That is to emphasize that it contains the sulfhydryl group. Sulfhydryl. So you have sulfur. We have sulfur bonded with hydrogen. Now, this consists of vitamin, which is pantothenic acid. So, you have here. So, this is the picture. This is the vitamin portion of the coenzyme A. And you have there another portion, mercaptoethylamine. Then this one is the phosphate containing portion. So you can see here the phosphate. So this is the citric acid cycle, of which you will be discussing that after we discuss glycolysis. So we'll discuss first glycolysis. Okay. Now, as what I have said a while